This problem is from Objective 2 of the recently released TAKS questions. In the United States, currency is removed from circulation when it wears out. The scatter plot shows the average lifespan of different denominations of U.S. currency according to the U.S. Federal Reserve System. And we do have a scatter plot. Along the x-axis, we have the denomination of the bill in dollars. They've listed 10, 20, 50, and 100. But looking here, I see that 1 is also on there, as well as 5. On the y-axis, we have the average lifespan in years, and that ranges from 0 to 9. Looking here, it looks like a $1 bill lasts about a year and a half. The 5 lasts about 2 years. The 10 about 3 years. And we could list this as in a T-chart. We could call it, we've got our X, which is our input, and our Y, which is our output. Looks like 1 is about 1.5. The 5 is about 2. The 10 about 3. The 50 looks like about 9 years. And the 100 again looks like 9 years. All right, so looking at the scatter plot, in the beginning it has a pretty constant rate of change, but as the bills get larger it levels off. So it doesn't completely have a constant rate of change. We could check the rate of change here also. Let's talk about some of the parts of the graph. Of course, we've got our X and Y, also known as our input and output. Let's just list some of the terminology for the X values. They're the input. They make up the domain. And they are independent. The Y values, that's our output. They make up the range, and they are dependent. All right, let's look at our question. Which is a correct conclusion based on the data in the scatter plot? The data represent a linear function. This is choice A, linear function. Oops. Let me get a different tool here. Okay, linear function. We know that linear functions create a straight line. And as I showed you just a minute ago, that is not a straight line. So I don't think it's A. B, the independent variable is the average lifespan. Independent. Okay, and I've labeled these already. Our independent is our input. And that isn't the average lifespan, it's the denomination. So it's not this one. C, the bills of smaller denomination have a longer lifespan. Oh, we looked at this also. Smaller denomination, that's these in this area. And I can see we already talked about it, they don't last as long. The $100 bill and the $50 bill last 9 years. These did not last long at all. So no, not that one. And D, let's hope this is the right answer. The average lifespan of a bill depends on its denomination. So the average lifespan depends on denomination. Yes, this is our output. It depends on the input. Our range depends on the domain. The dependent depends on the independent. So yes, we agree with that. So this problem had a lot to do with vocabulary. If you know your vocabulary, I don't think you'd have much problem with this problem.